If you are around computers long enough, you start to pick up on little buzzwords now and then. You may have heard the term IP address, but what is an IP address? An IP address, or Internet Protocol address, is a set of 4 numbers separated by periods. To you and I, we can almost think of it as a phone number. When your computer makes a call or communicates with another computer on the same local area network, it can't actually send the data that makes up the communication directly to the other side using just the phone number. Timeout. While an IP address is an address for a computer on the internet, computers can actually use these addresses alone to talk to other computers on local area networks. Why is this? Well, IP addresses are changeable addresses, kind of like phone numbers that can also be changed. Let's say we want to send a message. Look around this neighborhood. Can you tell which house has the phone number 610-555-4921? Probably not without a good guess. Now, which house has IP address 192.168.1.2? You just don't know for sure by looking at them. Every computer has its own address that is not changeable, unlike phone numbers or IP addresses. This is an actual physical address that is hard-coded into each computer, and that's called a MAC address. In this neighborhood, every house has its own physical address that is not changeable as well. So how does a computer learn these physical MAC addresses when all it has is the IP address it wants to send to? ARP to the rescue. ARP, or Address Resolution Protocol, requires that the sending computer broadcast a message containing a question to each computer on the local area network. In our neighborhood, ARP would ask each of these houses if they have the phone number 610-555-4921. But in the computer world, ARP simply asks each computer on the local area network who has 192.168.1.2. Basically, who has the IP address that we're trying to send to. So it'd be kind of like sending a message to every house within a neighborhood, only simultaneously. I'm sure you can guess which computer answers back, the one that has the destination address. The remaining computers just ignore the message entirely. What's in the message? The physical address of the destination. In an actual network, the computer with the destination IP address we're trying to send to would reply with its own MAC address. When the sender gets this key piece of information, they are free to converse with the destination all they want because they now know the actual location of the destination, so they can have a very real and physical place to send the information to, not just some changeable phone number or IP address. And this completes the communication process on a local area network.